Welcome to this module in the Titration video series. We're going to be talking about the policy lifecycle. I'm Tim, and I'm joined by Remi. So, Remi, what exactly is the policy lifecycle about? Why are we describing it as a lifecycle? Why isn't it just a static object that we're talking about here?
I'm not quite sure, because normally, you just take a policy, you put it somewhere, you hit enforce, and then you go back to bed, right? That's how it works.
I wish that you could just go back to bed, but unfortunately, the way that we've found policy has evolved over time. We've noticed that it's not really a static thing. It's actually a living, breathing entity. When we're talking about policy with end users, with customers, they come to us and say, well, I put a policy in place, but then the next day the application changed, or the application scaled out, or we migrated that application to a new data center, and I had to go back and update that policy. Or if I didn't update that policy, that application broke. So that's why today we're going to be talking about the policy lifecycle and exactly how you keep policies fresh and up to date and make sure that they are always in line with what the application team wants to do.
So wait a minute, you're telling me that the application is not as per the initial design, which was done when the application was deployed, and all the updates and so on don't change behavior of stuff? That's what you're telling me?
Unfortunately, when we're on the infrastructure side, when we're trying to secure those applications, the reality is no, they change all the time. Whether it's on purpose, because the application team has decided to upgrade that application or add some new service to it, or if it's because of some sort of event like a disaster recovery, the policy changes, the behavior of the application changes, and therefore whatever we are doing to secure that application, it needs to deal with that change.
Okay.
So to deal with that constant ever-changing nature of applications and the ability to keep the policy up to date, we have a policy lifecycle integration. It's not really something that we can put on a piece of paper, but it's more of a kind of discussion about exactly how you automate the workflow, how you deal with the workflow of keeping that policy refreshed and up to date and turn it into a loop. So let's take a walk through what we believe the policy lifecycle looks like.
It sounds like you're going to bring me one of those consultants kind of thing with a nice circle running around, or is it?
You know, I would love to be a consultant and earn those big bucks, but I'm going to try to keep it simple today.
You have to wear a shirt, though.
I would have to wear a shirt, and you know that's not me. No. So what we want to do is define the most simple way that we can describe a policy lifecycle without getting too complicated. So we'll start with a blank screen, which is nice, always. Okay. Fresh slate of paper. And in many ways, when we're talking about the policy lifecycle, it is important to actually clear your mind of previous assumptions about what you might do or not do when it comes to policy. The Titration policy engine is slightly different than how you might have typically thought about policy in the past. So we're going to start right up at the top here with the initial phase of defining the policy lifecycle, which is to define the application scope.
Okay, how do I do that? What is a scope to start with, and how do I do anything with it?
Well, a scope really is just a collection of workloads. It could be one virtual machine, it could be 10 bare metal servers, it could be a whole load of container pods. The way that we define scopes, we actually covered in another module. So I would recommend, if you want to get more details on exactly what you can do with scopes and how you define a scope tree, I would recommend that you do check that module out. But for today, we're going to assume that we've defined an application scope that covers the workloads that are part of this application.
Okay, how many workloads are we talking about in a scope, roughly? Like 10, 100, 1,000?
So because scopes are a hierarchical tree, they can be anywhere from one, it really can be as detailed as one workload, all the way up to tens of thousands of workloads, maybe even hundreds of thousands of workloads. Although typically when we're talking about application policy and the lifecycle of application policy, we're going to be talking on the order of 10 to hundreds of workloads because it's just for that specific application. Each application is going to have a unique set of policies, and Titration is going to help you automate the lifecycle of each one of those applications independently.
So you're telling me that basically the human is the problem, because if we put too many policies in one workspace, he gets lost, so we'd rather just make them a little bit smaller. Is that the goal?
That's the goal, right? Okay. We could actually get the system to handle everything behind the scenes, but by apportioning things up into slightly smaller logical units of per application scopes, as a human, when we go through to read those policies and evaluate them and understand them, it's going to be clearer for us.
I see. And if I'm a superhuman, can I run like thousands of policies inside one scope?
So you can potentially do thousands of policies in one scope. There is no limitation on it, but last time I checked, you weren't a superhero, Remi, so...
You didn't see me this morning, that's why.
Not this morning. Last night you didn't look like a superhero either. So we've defined our application scope, which is basically the selection of workloads that we want to build this policy for. And then the next thing we're going to do is actually run ADM. I just threw a term out there, right?
Yeah, so you're trying to try a bit of titration bingo inside it?
Yeah, we'll see how many different terms we can come up with today, but let me explain ADM. So ADM stands for Application Dependency Mapping. So what we want to do is essentially perform two tasks for you in an automated way. We want to understand which workloads are grouped together based on their behavior, based on their similarity. And then once we've done that grouping, we want to work out exactly who do they communicate with, who are they dependent on. And that's really the dependency mapping part of application dependency mapping. So you're just going to give us a set of machines or a set of workloads. Titration's going to run machine learning on top of that. I know you've been waiting for that fancy machine learning word. We tick the box there. And then that is going to produce for us a set of policies, basically. It's going to have a list of policies for that application and which workloads are grouped together.
So wait a minute, now I'm confused. You said that the app scope is a grouping of workloads. So now you're talking about machine learning and you're talking about a different type of grouping?
Yeah, so the application scope really defines the broad grouping of an application. You know, we might have the HR application, we might have the banking application. And typically, a lot of organizations can pin down workloads to a given application. But what's happening inside that application, usually that's just a black box in many ways. So Titration's goal is to take that object of an application and split it up into smaller subcomponents that you can then apply microsegmentation on top of.
I see. So actually what you're telling me is that when you're talking about big groups, it's okay to have big groups there because what you're telling me is that ADM will actually create smaller groups and define the policies for me automagically?
Automagically.
Okay. Curious to see that as well. But
yeah, and we're definitely going to cover that in a lot of detail in our ADM module, exactly how Titration performs that ADM and how you analyze those results.
Okay.
Today we're just going to, or in this session, we're just going to discover exactly what the entire loop of policy lifecycle management looks like.
Okay.
So let's assume that ADM has come up with a set of groups for an application and policies for that application. You might assume that the next part is to go straight ahead and enforce those microsegmentation rules.
Let's go and enforce. Let's hit the button.
So that might be the assumption, and that's what a lot of end users, a lot of customers have attempted to do in the past. I have my policy, I'm ready to enforce. However, we found that there's a critical step in the middle that you really want to think about, which is, you know, is that policy actually going to work? Is it going to cover all of the parts of that application? Is it going to deal with all of the behaviors of that application? Or have I missed something? Do I need to go back and tailor that policy a little bit? And that's really where Titration is going to help you. So the first thing that we're going to do in the policy lifecycle is take the output of that application dependency map, visualize the results, visualize it in a way that makes it very clear to you as a human what that application is doing.
Well, just hang on a minute. You have a crystal ball?
Don't have a crystal ball.
So how do you know it's going to work or evaluate or test even the policy?
So the part that we're going to try work with, and as we go through this, we're really going to try and understand how the quality of the data that Titration collects means that what we build is going to be highly accurate. We're not asking you as an end user to go through and actually validate every single policy.
Okay.
We're going to use big data analysis to actually work out, is this policy working or not? What this section really is just about a general kind of overview of those policies, a sanity check, if you will, to make sure that what has come out of the system reflects what you believe should be happening.
Okay, so you're telling me that it has some form of view that allows me to see what's going on at a super high level in there. So we're not really doing any simulation at this point. We're just looking. We're
just looking, and it's going to draw us a nice, pretty little diagram exactly about what that application is doing. Who's talking to that application, what the dependencies inside that application look like, and also who it's speaking to outside of the application. And I'll tell you, there's many times where we've actually seen the output of this where it's surprised people about exactly what those applications are doing.
Okay, let me guess. Dev talking to prod?
Dev talking to prod, one of the repeat offenders. Applications talking to websites on the internet that it shouldn't be talking to, unauthorized users accessing internal applications that they really shouldn't be doing. All of those kind of things become very clear when you visualize the results of application dependency mapping.
I see. So this visualization is targeted to higher level people. So like I'm guessing from what you're saying and the examples you're giving is that I'll see like a sort of stick diagram of applications, and then as an application owner with absolutely no understanding of networking or security and so on, I look and it seems okay to me. Is that the idea?
That's the idea.
Okay.
You're not going to see all of the information about the IP addresses. You're going to see a little bit of information about the services, but you don't need to understand networking at a high level or even a low level to understand the outputs of Tetration ADM.
Okay.
So this really is something that you can give to the application developer. You could even give it to someone in the executive suite to understand what that application looks like, and they're still going to understand it.
Yeah, let's not push it too far.
Let's not push it too far. So once we've gone through and visualized those results and we are comfortable with what Tetration has produced from ADM, we can actually begin to start doing some deeper analysis. And that's where we're going to validate the clusters, the grouping of the endpoints, and we're going to approve those, which says to the system that I was happy with the results of that grouping. I would like to go forwards and start analyzing the policies. And at that point, we're going to start approving our policies using our policy analysis engine.
I see. So just if we go back a little bit, when you say validate and approve the clusters, I remember in a different video series the mention of tags and stuff like that. So is tagging the way I would kind of look at like some metadata coming by some other system that would allow me to say, oh, that's right, that's wrong in there? Is that the only thing Tetration uses, by the way?
So it's definitely not the only thing that Tetration uses. We take a huge amount of signals that go into actually coming up with what those clusters should be. One of which is the tags that are present on the machines that are being grouped together. If I see lots of workloads that are exhibiting the same behavior on the network, also have the same tag applied to them, it's a very high chance that they should be grouped together. However, it's not just network data that we're using to build those clusters. It's also parameters such as the process that is running on that workload or the load balancer that it sits behind. There's a lot of insight that goes into the Tetration ADM mapping algorithm to come up with that final cluster. And obviously, as the end user, when you are working with Tetration, you can actually look at those policies, look at those clusters, and see some of those insights as to what group those workloads together.
Okay, so what you're telling me in short is that tag is nice, but actually, even if my tags are wrong, the grouping will actually be accurate based on the process and the flows and so on. And so in short, when I'll see and I'll go to the validate the clusters things, I can now go and see that, hey, you know what, those 3 servers have a tag, the 4th one doesn't have a tag.
Yes.
And that would still show me the right grouping of servers.
Exactly. It's based on the behavior. It just happens to also give you more information about the metadata that we know about those workloads. And that will help you improve the tagging of your workloads. If you realize that you missed one of those, 3 of them are tagged, 1 of them is not, you'll be able to create that tag, add that tag onto that workload, and potentially even synchronize it back to a CMDB if you need to.
Pretty nice.
Yeah.
I can't wait to see this video series.
Yeah, it's going to be fun as we get to that.
Hope so.
So we can approve our clusters. We can potentially approve some of the policies if we want to, if there are some policies that we clearly know are supposed to be there. For example, an application accessing Active Directory or speaking to a DNS server. Those policies we can approve at a very high level very quickly. But when it comes to potentially policies inside the application, intra-application dependencies, it's very useful to start using the machine learning that we have, the big data analysis that we have to actually validate that application policy. You know, one of the things that we've experienced as we've started helping customers move to policy enforcement is that not everyone knows what their policy should be for the application.
How surprising.
How surprising. In fact, that's obviously why we have ADM. But then you get a chicken and the egg situation, which is, well, I had to use ADM to discover the policy. If I don't know the policy, how can I validate the policy? And that's where we use flow data to go and validate that policy. So what we'll enable you to do is look at the output of ADM and compare it against the flow data that we're currently seeing live on the wire. What that will then show you is, would that traffic be allowed as per the policy, or would it be dropped as per the policy?
Okay, I see. So if I look at what you were telling before, that's more Instinct? Instinct is the English word, right?
That's a
Thank you.
English word.
Always check with the British for
Yeah.
that. So that's instinct-based. I look, it sounds right, it feels right in there. That's proper validation.
Correct.
I see.
This is going to help you get to the point where you can actually empirically say 100% of the traffic of this application is matching a segmentation rule. And when I enable segmentation, I am not going to drop any traffic for this application.
Okay.
Now, you can do this for the live traffic, but also you can do it for historical traffic. That becomes important when you start dealing with applications that have some seasonality to them. Imagine a banking application. Those banking applications might have to do slightly different things at the end of a quarter or around tax season. So it's useful to be able to have stored flow data from many months ago and apply that same sort of analysis that we could do on live data against that stored data to validate that those time periods will also be covered by our segmentation rules.
I see. So things like, I mean, I wish that would fail, but like bank statements, for example, at the end of the month,
Yes.
you would say that, hey, you could take the data for like, say you're on the second of the month, your cluster has been running earlier. You could say, hey, titration, tell me how the policy would perform against this time period.
Yes. Yeah. And
That's a
you'd be
promise, isn't it?
surprised how many applications do have that seasonal behavior to them. So when you are developing policy, you really want to be able to make sure that you have a very wide range that you're looking at that policy analysis for.
But does that mean I have to run titration for 2 years for a thing to actually provide results?
No, absolutely not. So it's an iterative process. It grows over time, and that's actually the next step of this cycle. So the whole goal here really is to make a closed loop of policy analysis. You want to analyze your policies, you want to monitor them, and you can do this in a listen-only mode, so you're not actually touching anything on the network. And you can choose to do that for as long or as short as you want. So if you're talking about a non-critical application that you're fine with just 1 day's worth of analysis on that, hey, that's totally fine with you. But if you want to check for 30 days, 60 days, 2 months worth of time, or even 3 months, I should say, you can definitely use that compliance engine to actually monitor in a listen-only mode for that entire time, constantly tweaking the policies, rerunning ADM if necessary, and getting that compliance to update so that you can really ensure that you've got every single behavior of that application covered.
Okay, so let's say I do your process. I've gone through scope definition, ADM, visualization, validation of clusters of policies, then I analyze, I monitor, I make a change, which seems okay right now, or someone in my team makes a change. That's a possibility as well. What happens if I need to revert it? Because, I mean, you mentioned it earlier, like some servers talking to sites that they shouldn't be talking to, right? Yep. If I decide to allow it because maybe a junior guy in my team just saw it and he said, okay, cool, let's just approve this flow.
Yep.
How do I know that something was done on that? And how can I revert it? So where can I find when it happened? Who did it?
So we like to monitor everything in titration, not just what's happening inside the network or on the applications, but also what's happening inside the titration cluster. So every time someone makes a change, whether that's approving a cluster, validating a policy, or adding or removing a service, that's going to be tracked. Most importantly, it's going to track who did it, so you know who to go chase.
Awesome. Someone's paying for beers.
Yes, and then there's always the rollback function as well. So even if someone accidentally messes up all of the data or messes up all of the policies, it's just a simple click to go back to the previous state of that application.
Okay, so I can play around, like I can share it with my team, I can empower them to some extent to play around with policy, and when they're done, I can give them a sort of cutoff points where I can just go and look at diffs between policies and say, okay, why you do that, why you do that?
Yes.
Very nice.
And of course, everything is also accessible over APIs. So if you wanted to bake this into your own automation systems, into your CI/CD pipelines, into something that was outside of the titration UI, totally fine as well. You don't necessarily have to do this all through our system. If you wanted to integrate your own custom policy UI into that, that's totally fine as well.
So I could integrate that with my SRM, for example, to raise a ticket every time someone makes a policy change, something like that. I could do that.
Yes, you could do that.
Very sweet.
Yeah. It's all about that compliance, right?
Yeah.
You've got to track what's going on.
I've seen your promise count going up and up and up and up. Remember, you have to demo all of that.
Yeah, I'm definitely in debt with promises at this point. So once we've monitored for compliance and we are really happy that we've actually covered all of the traffic profile for that application, we can move on to the next step. And the next step in this process is going to be enforcing
red
policy.
button.
The big red button, or in the case of titration, the big green button to enforce policy.
Green is good.
Green is good, and that's because this is not a scary part of the process. Now, in a lot of environments, when I walk into a customer environment and they've attempted a micro-segmentation project in the past, the enforcing policy part of that process is typically the most nerve-wracking part for them because they've been bit in the past. You know, it's quite common for people to talk about horror stories in the industry where they went ahead and tried to do micro-segmentation and they didn't capture this dependency, or they didn't think about this flow, or they didn't correctly group those endpoints and everything started going on fire. That's really not going to be the case with titration. And the reason is we've already gone through all of these steps before we get to the point of enforcing policy. We've generated policies automatically via machine learning. We've been able to validate and check for compliance with those all in a simulation-only mode before we actually get to that enforcing policy stage.
That's interesting. A question that when you were talking through that, I was thinking, are you aware of any customers that actually are in micro-segmentation, full micro-segmentation in their environment today?
There's lots of titration customers that are currently doing...
Non-titration customers.
Oh, non-titration customers. I've found that it is a very rare occurrence to find a customer that is doing micro-segmentation in an infrastructure-based way. We're finding that it's more common to have attempted micro-segmentation projects, potentially got to some level of segmentation, but not gone all of the way. And it really comes down to the fact that it's just so difficult to understand what the policy should be, and is that policy going to work? That is really the crucial part of the policy lifecycle. The enforcing part is actually one of the smallest parts of the policy lifecycle. It's just simple, taking rules and pushing them down to some sort of enforcement device, whether that's in the network or whether that is on the host. But it's all about validating, analyzing, and continuously updating that policy to make sure it's going to continue to work.
So you raise a good point. So what you're telling me basically is that this is the critical phase here.
Yes.
And that most of the reasons why people don't get to that stage is because permit IP any log doesn't scale.
Yes.
In short.
In short, you have to take a new approach if you want to get to micro-segmentation. And we believe that this approach enables you to do it without basically losing your hair or your hair going grey. And you know I don't want to lose my hair, right?
No, I know that very well.
So once we get to the enforcement stage, this is actually part of the titration product as well. This is not saying take the policy that we've discovered and put it into a network controller or into a firewall or into some cloud provider's policy. We're talking about natively pushing the rules directly from the titration appliance down to the workloads themselves.
Okay, so you're telling me that you're going to take the agent we discussed in a different module, and magically this agent is actually going to do the segmentation job directly wherever it sits.
Yes. You can think about it almost like a hyper-distributed firewall. Instead of having firewalls at choke points in the network, you have a firewall running on every single workload. That could be thousands of firewalls, but each one is very small and is doing a very specific job. Each workload is only enforcing the policies that are relevant to that individual workload. So you might have hundreds of thousands of policies that are in place across the entire network, but each workload might only be enforcing 10 or 100 of those policies. And that's a very scalable and efficient way to enforce that policy. And on top of that, it's totally infrastructure independent. I can enforce the same policy on a workload that's running on a bare metal on premises as I can on a container pod running on top of Kubernetes in the cloud. It's a very flexible way to enforce policy in a consistent way across all of your application workloads.
That's pretty nice. So the policy will go down. But you're also telling me that, say I have, I don't know, 30, 40, 50,000 sensors across my environment. Let's say go crazy, 120,000 sensors in my environment. Titration will take the policy I define, so those simple constructs. It will help me simulate it. It will help me test it. It will help me visualize it in the environment, monitor it, and when I hit enforce, it's actually going to go and render 120,000 individual policy?
Correct. Yep.
That's pretty nice. So 3 days roughly runtime? No. Only joking. So yeah, I'm guessing it's pretty, it must be pretty fast, I guess.
Yeah, it's actually very, very fast. We have a consistent SLA of the time that you push the policy to the time that it's going to update of 60 seconds. And that is going to include whether you're looking at 10, 1,000, or even 100,000 workloads. our policy engine is designed to scale in a linear fashion no matter how many workloads that you are using.
Very nice.
So,
okay, so we're enforced around over 120,000 apps in our banking application.
yes.
So 120,000 sensors, sorry, across banking environment. Now what?
Well, we have the policy enforced, but we probably also want to check to make sure that that policy is being followed, right?
That would be useful.
That would be useful. And in fact, this is where whitelisting really comes to play. Because when you're whitelisting, you're allowing only good traffic that you expect to be on the wire. And what that allows you to do is very quickly detect any traffic on the wire that does not match a whitelist rule. Now, if you're enforcing your policy correctly and you have all of your agents deployed, it's very unlikely that you'll start seeing any traffic that is non-compliant. But let's say, for example, that you were breached or someone misconfigures something, that traffic is going to start appearing on the wire. The Tetration agents are going to report that telemetry to Tetration, and it will then go and actually help you understand and alert to you very quickly that there is non-compliant traffic on your network. So that's really where we can generate compliance alerts.
I see. Where are you putting those alerts always? Because I would say, my security guys, they receive about 1 zillion alerts a day across 20 different tools. So is that the 21 tool?
So the good thing is there's two parts to the answer. Number one is that our alerts are very high precision. Because we've done such a complete job of analyzing the policy and making sure that we've captured all of the state of that application, you're not going to be getting tons of false positives about this shouldn't be happening, this shouldn't be happening. We have a very good picture of what is the normal state of that application. So when we do generate compliance alerts, they are going to be very serious alerts that you really should pay attention to look at. Now, we'll raise those alerts with inside the Tetration platform, but like you mentioned, nothing is an island, and Tetration fits into the wider portfolio of whatever the end user or the customer has deployed in their data center. And so that's why we run Apache Kafka within inside the system, and that allows you to consume those alerts in a standardized format. So anything that can consume from a Kafka message bus will be able to pull those alerts in and do whatever you need to do with those alerts. We also include out-of-the-box connectors that allow you to generate things like Slack messages, emails, even push it up to things like AWS Kinesis.
Emails, really?
Emails, I know.
Okay.
We're filming this in 2019 and we're still talking about emails, but
yeah.
We also do have syslog as well, if you want that.
Oh, yeah, syslog. Oh my God,
I know.
1998 now.
I know. So obviously we would recommend that Kafka is the right way to go for this because it's the most scalable way, especially if you're talking about 120,000 workloads that you're monitoring. You need a scalable way to get those alerts out. But if you still are relying on tools that deal with things like email or syslog, the capability is there inside Tetration as well.
I see. Well, that's pretty interesting. So if I summarize my understanding, what you mentioned here is actually applicable in any case, not only Tetration. The difference is that Tetration built an engine that actually helps you go through all the steps in one go versus maybe using parameter IP and E-log here and using Excel spreadsheets.
Spreadsheet analysis over here.
The great spreadsheets. And then manually using a Visio file and then sending this Visio file to a whole bunch of people and then having to handle with the email trail in there. And then finally, monitoring, so that you're literally reducing the load on the monitoring guys, whoever owns the tool, security or ops there. You're distributing enforcement, which means I guess I need less big boxes everywhere because my traffic is not hairpinned all the time.
Correct. And you don't have to spend so much time translating policies from one configuration format to another configuration format.
That's fair, but actually you raised a very good point. What if I have some places, because obviously you heard about this defense in depth story and so on.
Yep.
What if I want to enforce, because I'm not going to remove my firewalls, ever, right? I mean, that sounds a bad idea just off the bat.
Yeah, and I wouldn't even ask you to remove your firewalls. It's very important to have firewalls at the edge of each of your environments, physical firewalls or virtualized firewalls.
Okay, so how do those things work? Is there a way for me to get the policy out of Tetration, which is sort of, vendor agnostic is always a very interesting term, but at least something that doesn't require me to sign a partnership agreement and all that stuff. Is there something I can do?
Of course, and it's out of the box as well. So every time that we push those policies down to those workloads, We also take a copy of the entire policy set, whether that's 10,000 policies or 100,000 policies, and we place those policies on that Kafka stream again. So in the same way that you could consume alerts, you can also consume a fresh version of that policy. We put it in a standardized format, and then if you want to take that policy and use it to automate policies on other devices, whether that might be firewalls or configuration on hypervisors or on cloud providers, you have that policy in your hands as the end user that you can interact with and replicate across your environment as you see fit.
Okay, great. So that means I don't need to go and get developer API key, come in from the vendor and sign about that much paperwork and so on.
Zero paperwork to get started with this. In fact, it's all open source and available on our GitHub account.
Pretty nice. So you're saying that actually all this then up to here, I can enforce down to software sensors, but I will also give the policy out so I can actually go and deploy defense in depth if I feel I need to, or I can just stick with whatever I have with host-based enforcement.
Yep, you got it.
Cool. And then when I generate the compliance alerts, send it all out to the SIM, and that's it?
And that's it, and that's the policy lifecycle. And like you mentioned, this is not a lifecycle that we just walked into a room with no prior thought and drew on a board. This is based on years of experience as part of the data center and security teams here at Cisco. We've been involved as the Tetration team with a huge number of micro-segmentation projects, a huge number of those projects where we've really learned from being in the fire exactly what it takes to get to that point where you can truly say that I have a policy lifecycle implemented and I'm comfortable with enabling segmentation. So this is learned from experience with customers.
I see. So it's not just a marketing diagram.
It is not just a marketing diagram. Even though it does look beautiful on the piece of paper here, it is each one of those steps is there for a reason. And if you miss any one of those steps in your policy lifecycle, in many ways you might be doomed to fail.
I see. Well, it was pretty interesting so far. So all in a box.
All in one system. No external systems that you need to plug in. Policy management, policy enforcement in a box. And in later modules of this series, we're going to actually walk through each one of these steps. We're going to look at how you can define scopes, how you run ADM, how you visualize and pass those results, how you validate and approve those policies, how you do policy analysis to check for compliance, how you enforce that policy and what that looks like, and finally the type of alerts that you would get out of Tetration.
Okay. And I would say all that I can run it as many times as I want, right? It's not like once you've done it once, you're stuck.
I wish we could charge per run, but no. You can run that as many times as you want. That's the whole goal. This is a life cycle. You might want to rerun and start this loop again every week, every month. You really want to think about how often is the rate of change in my environment expected, and how do I deal with the updating of policies. So this whole thing really is very easy to get into a nice cycle.
I see. And say, I'm special, of course. If I decide to go from ADM to enforcement, do I have to follow the rest, or can I just go there?
I'm never going to force you to do anything in life. And you can also go straight from running ADM to enforcing policy. Especially if you're in a lab environment, for example, you don't have to step through each one of these steps. You don't have to wait a whole month for policy analysis to come through. You can go straight from running ADM to enforcing policy. And in many cases, ADM gets all of the data ready there for you, so you don't need to check for compliance. But in production environments, obviously, we truly would recommend the rest of these steps to make sure that you aren't skipping anything critical.
Yeah, that makes sense. Cool.
Okay. Well, with that, we're going to wrap up this video in our Tetration video series. I thank you for joining us. If you would like more information about Tetration, please go to cisco.com/go/Tetration.